Right, everybody. We're going to go over that last problem that we were working on in class. I just wanted to kind of reiterate the steps of how to go about solving that. So we're talking about, in this particular case, right, we're talking about carbon dating. And it's how they determine the age of a fossil. And so we're going to use that formula we were talking about in class. That formula was N of T is equal to N sub 0 times e to the negative kt. T is time, and k is that rate of decay, or the decay constant. The rate and constant, it just means the same thing, but let's figure out what that decay constant is. N sub 0 is our initial amount, and N of T is what our final amount is. So if we're talking about half-life, right, if we start with 1 of something, we want to end up with half of it. Okay, so the first thing we're trying to figure out is K, and then we'll use that to figure out the age of the fossil. Okay, so the first thing we need to figure out is the decay constant for carbon-14 specifically. Okay, they didn't give us that, so we need to figure that out. Okay, so we use this formula for half-life because we know that if we start out with a whole of something, we can use this formula to figure out how long, or how we get half of it, basically. Okay, so I have E, and I have this negative K because that's what I'm trying to find, and they told me that the half-life is 5,730 years. Okay, so 5,730 years is the half-life. Okay, so I'm starting out with a whole. I want to figure out, I know it takes 5,730 years to get half of carbon-14 of what I started with, but I don't know what the rate is that gets me to the half. So that's what I'm trying to figure out. I'm trying to figure out that decay rate, or that decay constant. Okay, so all I'm going to do then, let me rewrite this. So I have 1/2 is equal to 1 e to the negative 5730 k. Now, from class today, well, first thing we have to do is we need to take the log of both sides because our variable is in our exponent. When your unknown value is in your exponent, then you need to take the log of both sides. Okay, so because I'm dealing with base e, instead of saying log, I'm going to say ln. So I have ln of 1/2 is equal to ln. Remember, this is 1, so I don't really need to write it. So I just have ln of e to the negative 5730 k. Now, this side I can rewrite as ln of 0.5, right? 1/2 is just 0.5. And over here, we talked about this in class today. If I'm taking ln of e to some power, the answer is just whatever that power is. So that power is negative 5730 k. And so to solve for k, I'm just going to divide both sides by negative 5730. Okay, so this is negative 5730. And so we can do that in our calculator. Quit out of there, clear that out. Okay, so I have ln of 0.5, and then I'm going to close my parentheses, and I'm going to divide by negative 5730. Okay, and that's what it gives me. So 1.2096 times 10 to the negative 4th. Scientific notation, right? That's the same as moving this decimal point 4 places. So 1, 2, 3, 4. And I end up with 0.00012 approximately. Okay, so that gave me my constant. But remember, I need to figure out the age of the fossil. Okay, so now that was step 1. Now in step 2, here's step 1. Step 1. And I'll do step 2 in blue here. Step 2. I'm going to use that same formula, N of T is equal to n sub 0 times e to the negative kt. Now, there's information in the problem that I haven't used yet. Okay? He analyzes fossil and concludes that the specimen contains 15% of its original amount of carbon-14. So what I currently have left is 15% of the original amount of 100% that you started with. Okay, so there's 15% left of what you started with. So the starting amount was 100%, and now we're down to 15%. I figured out what K was in part 1, and now I'm trying to find T. Okay? Now, again, my variable or my unknown value is in my exponent, so I need to take the log of both sides. Because my base here is e, I'm going to use ln. So I'm going to say, okay, well, ln of 15 is going to equal ln of 100 times e to the negative 0.00012 t. Okay. Now, we can do it this way, and it's going to be, well, I'll show you. We'll do this. ln of 15. Remember, this is the product of two things. Okay, so remember, we can use our rule. We had a product rule that said I can write this as ln of 100 plus ln of e to the negative 0.00012 t. Okay. So I want to get this term all by itself. So let me subtract ln of 100 from both sides. I end up with ln of 15 minus ln of 100 is equal to ln of e to the negative 0.00012 t. Now this goes back to one of the properties we talked about today. We did the same thing over here. This should actually just equal my exponent, so negative 0.00012 t. So if I take the natural log of e to something, my answer is just that something. Okay? Over here, this I can do in my calculator. I can say ln of 15, close your parentheses, minus ln of 100, close your parentheses. It gives you this long decimal, right? So negative 1.811, whatever it was. Or 89711. 89711. If I now divide both sides by negative 0.00012, then I can figure out what t is. So in my calculator, right, I can just take that answer. So if I do second answer, that pulls up my previous one. So if you do second and then the negative sign, it pulls up your previous answer, divided by negative 0.00012, and that means it would take 15, or the fossil is 15,809 years old. Okay, so that's all you're doing. You're just doing that process of using that formula twice. The first time to find that decay constant, the second time to find the time. So that's the idea behind that problem. There's only one problem on your assignment that is kind of similar to this, but that's the formula that you're going to use. Okay, everybody, have a great day. See you next time.